This problem asks us to use Euler's method with increments of change in x equals negative 0.1 to approximate the value of y when x equals 1.7. The problem says the derivative of y over the derivative of x is equal to x minus 2y, and y equals 1 when x equals 2. Euler's method, the formula for Euler's method is basically y of n plus 1 is equal to y of n plus h times the derivative of the function of x. So we can create a table to solve this problem. We can create it of n, then x sub n, and y sub n. And our h value is going to be the change in x, which is equal to negative 0.1. So the first n is 0. The second n is 1. The next is 2, and the next is 3, because that's how many we're going to need since we're going to x equals 1.7. So the given is that we start with y equals 1 and x equals 2. So from the beginning, we can just say x equals 2 here and y equals 1 here. Then we'll have to figure out, using the formula, all of the rest of the y's. So when y equals 1, we need to figure out y of 0 plus h, which we know is negative 0.1, times the value of f, and this should really be x sub n, of the derivative of x sub n. And so based on substitution, we can plug in our value of x sub n of 2 and y sub n of 1, and we get y naught is equal to 1, and then plus negative 0.1, multiply that by the derivative of 2, and so now we need to find what the derivative for the value at x equals 2 is. So this actually uses both the x and the y value. So important distinction to know here is that we should be including both the x and the y value. So to solve this problem, we need to do x minus 2y, and our original values for that was equal to an x of 2 minus a y sub n value of 1. So that would be 2 times 0, 1, which is just equal to 0. That's going to simplify to 0, which means that the right side of the equation is just going to be equal to 1 plus 0, which means y 1 is just equal to 1. So we can put that now into our table, and we can say y1 is equal to just 1. And then we can say x sub n is equal to 1.9. We know 1.8 because this is going, and then 1.7. We can just put in the x sub n's now because we know what we're subtracting we're doing increments of negative 0.1. So our next step is going to be to find the next y2. So we'll use this formula again. We'll do y sub 2 is equal to yn, which we know is y1, and we got 1 for that. So we just put in 1 plus the value of h, which we know is negative 0.1 because it's our change in x, and then f, the derivative of the function of f at our x value, which is 1.9. So f and our y value. So we will need to use 1.91. So to find the derivative, we can get dy dx. We'll plug in our values. We have an x of 1.9. We subtract that from a y of 1, so minus 2, and we get a dy dx of negative 0.1. So y2 is equal to 1 plus negative 0.1 times this value, negative 0.1. Negative 0.1. This simplifies down to y sub 2 is equal to 1 plus, because the negative signs, there's two negative signs, which means it's a positive. So plus 0.01. So y sub 2 is equal to 1.01. Now we can plug that into our table. I'll just make it a little more organized. And then I'll clear up some more space so we can do our final step, which is y sub 3. For this step, it's the exact same as before. Essentially, we'll just say y sub 3 is equal to our past y value of 1.01 plus our change in x, which is negative 0.1, times our f of x, our x sub 2, our second x, which is 1.8, and our y sub 2 of 1.01. We can then use dy dx to find the value of the derivative. So we can plug in 1.8 for x minus 2 times 1.01 for y. From this, we can plug this into our calculator, and we get negative 0.22. So we'll go y3 is equal to 1.01 minus 0.1 times negative 0.22. Then we plug this into our calculator, and we get a value of 1.032. We can put this back into our table, and then we found out that when x is equal to 1.7, the Euler's method gives us approximation of y is approximately equal to 1.032. And that is our answer. Thank you for watching. Bye.